So question 7 asks us to find the equation of a line, and this equation has to have two properties. One of the things that has to be true is that the equation of the line we find has to go through this point. It has to go through the point x is negative 9, y is 10. And the other thing that has to be true is that it has to make a right angle with. It has to be perpendicular to the line 6x plus 2y is 46. So conceptually, if we look at this, I've got this point sketched right here. This is the point x is negative 9 and y is 10. And I'm looking for a line that goes through that point, right? And there's a lot of lines that go through that point, okay? But unfortunately, it's not enough to give a line that goes through that point. We want a special line. We want the line that goes through that point and it makes a right angle with, a 90-degree angle with, the line 6x plus 2y equals 46. Now, one of the things that we know is that if we have a slope of a line, let's say that this is down 2 over 1, right? So this is a slope right here. This is a slope of negative 2. If I want a slope that makes a right angle with that, what I have to do is I have to take the opposite sign and I need the reciprocal. So you can see this was negative, so what I need is positive, and the reciprocal of that would be 1/2. So if I drew a line that had a slope of 1/2 on this same grid, it would be up 1 over 2, right? You can immediately, pretty convincingly see that this line with that slope of up 1 over 2 certainly appears to be a right angle. Now, we looked at this earlier when we were rotating the Cartesian coordinate plane, and we demonstrated that, yeah, actually when we rotate the whole plane, that's what happens. The rise and the run switch places, and a slope that's negative becomes positive. So again, the big idea I want to make sure you understand before we do this problem is that I need to know the slope and a point that I'm going through, and then I can come up with the equation of this line. In order to get the slope, I need to know what the slope of this is first. And then I'm going to take the opposite reciprocal of that. So let's start by finding the slope of this line that I've underlined in purple. And to do that, I'm just going to go ahead and rewrite that in slope-intercept form. So I'll rewrite it as 2y is equal to negative 6x plus 46. So you can see on each side I've taken away 6 times x. And then I'm going to divide both sides by 2. So this becomes y is equal to negative 3x and then plus 23. So I found our slope. This is not the slope that I'm going to use. It's the slope of the purple line, right? The slope of the purple line is negative 3, and I could write it as negative 3 over 1. Now, the slope that I need to use, the slope that'll make a right angle to this line, would be a slope of positive 1/3. So notice two things happen. It's both opposite in sign. It was negative, it became positive, and it's the reciprocal. It was 3 over 1, it became 1 over 3. So at this point, I know a slope and I know an xy value. In fact, let me highlight these. I've got an x value of 9 and I've got a y value of 10. And the slope that I'm going to be using is 1/3. So I can write y is equal to 1. Let me just write this as a blank to start with. I'll write y equals mx plus b. Just reminding me that if I want to write the equation of a line in this form, I need both parameters. I need the slope parameter and the y-intercept parameter. So if I plug in the y value that I have, right, which is 10, and I'm also going to plug in the x value that I have, which is negative 9, and I will also plug in the slope parameter that I know, which is 1/3. The only thing that won't be a number will be the y-intercept. So we can write 10 is equal to 1/3 times -9, that's what x is, plus b. When I multiply 1/3 times -9, I get a -3. So this side becomes -3 plus b, and over here it's equal to 10. And if I add 3 to each side, I get that 13 is what b must be. So there we go. I now know my missing parameter. I now know my y-intercept. So at this point, I'm ready to write the equation of the line. So I can write y is equal to 1/3 times x, and then plus the number 13. So a nice way to kind of help cement this idea conceptually is to, let's go ahead and look at it in GeoGebra. So in GeoGebra, I went ahead and plotted the point. This is the point, x is -9, y is 10. And I also graphed the line that I was given, 6 times x plus 2y equals 46. If I was to get that into slope-intercept form, again, that had a slope of -3, and it had a y-intercept of 23, and I can see that that looks about right. So what we found to be our answer was the equation. I believe it's y is equal to, we had a slope of 1/3, and then x, and our y-intercept that we found was plus 13. And there we go. So what's nice is that you can see at this point that this line is exactly going through point A. So I'm definitely hitting -9, 10. That's important. And it also appears that I'm hitting the line that I was given at a right angle. Now I'd like to verify that. And to do that in GeoGebra, there's, under my tools, there's a measurement tool. So I'm just going to come down to measure, and I want to measure an angle. And I'm just going to select this angle by clicking on this point and then this point. And what it does is it shows me that they are indeed meeting at 90 degrees. So there's 4 angles here. All 4 of them are 90 degrees. 2 of them would make a straight angle. So absolutely, it's the case that I found the line that has 2 properties. This line, y equals 1/3 x plus 13, is going through point A, which is at -9, 10. And importantly, it is hitting the line 6x plus 2y equals 46 at a right angle.